a mechanalysis of Thomas Kuhn's The Structure of Scientific Revolutions. For many years, scholars believed that the history of science was linear, a rational progression characterized by the accumulation of knowledge. It took an American physicist and historian of science, Thomas Kuhn, to turn that understanding on its head. In 1962, Kuhn published a book called The Structure of Scientific Revolutions that claimed the development of scientific discovery was not linear, but cyclical. Kuhn believed that science was punctuated by revolutions that signaled major shifts in scientific understanding. He claimed that this cycle had a recognizable structure that was characterized by successive periods of normal and extraordinary science. What did Kuhn mean when he wrote that science is cyclical? Just as scientific evolution is dynamic and constantly changing, so too is the Earth we live on. The characteristics of Kuhn's scientific cyclical cycle can be compared to the environmental changes that happen on Earth. During the last ice age, the Earth's temperature stayed relatively constant. This can be compared to Kuhn's so-called normal phase of science, the period in the cycle where a scientific model of understanding is followed. Kuhn calls this model a paradigm, and he argues that in this phase, experiments and discoveries are made, but the paradigm is not challenged, just as the climate in the Ice Age remained largely unchanged. Then, a slight change in the Earth's orbit resulted in a dramatic rise in temperature. The glaciers began to melt. This shift in the Earth's orbit was the catalyst for massive environmental change. In Kuhn's cycle, this is the point when a scientist conducts an experiment that disproves the currently accepted paradigm. Just as the ice begins to melt, the old model of scientific understanding begins to collapse. It's at crisis point. With the composition of Earth's atmosphere altered, the weather becomes increasingly turbulent. In Kuhn's cycle, we've reached the extraordinary phase, which is equally unsettled. Scientists are all trying to find a new set of rules to move forward with. A revolution is underway. After a while, the Earth begins to settle and life adapts to this new climate. This is the final stage in Kuhn's cycle, where a new paradigm is discovered and a new set of scientific rules can be constructed. Scientists will then start to develop their experiments, and the next cycle begins. Kuhn's theory in the structure of scientific revolutions had widespread effect that reached further than just scientific circles. In fact, the term paradigm shift originates from this book.
Pre-paradigmatic phase, or the phase before the paradigm. Within this phase, scientists work separately. They use different measurements, research, and ideas, believing their ideas are far more superior and correct than the others. Essentially, everyone is working alone. It is only until a single idea, theory, or measurement, for whatever reason, becomes dominant that a paradigm is established. At that point, scientists work together to help to advance and perfect the holes within the paradigm, which leads us to the following phase of science: normal science. Normal science is the phase where a well-functioning paradigm has been established. It is a period in where scientists share a paradigm, determination of scientific facts, matching facts with theory, and articulation of a theory. Normal science points towards continuity, does not permit advancements by revolutionary theory. But in reality, paradigms do not always remain in the normal science phase. Often anomalies or inconsistencies of paradigms come about. Anomalies are problems, a deviation from the normal accepted paradigm that scientists are unable to solve. Kuhn believes that there are always anomalies present within every scientific paradigm. But if those anomalies concern the central importance to the paradigm, then a scientific crisis is reached. Moving on to the following phase of science. Crisis is the point where scientists begin to lose confidence over their paradigm due to inconsistencies and significant unanswered anomalies that don't provide important answers for paradigms. Scientists become interested in new theories and concepts outside of the paradigm they have been using for all these years. The scientific revolution, according to Kuhn, is the phase of science where one paradigm is abandoned while another is accepted. This is also referred to as a paradigm shift. A paradigm shift includes the massive change in the acceptance of scientific research, also understood as foundation change. It leads to an irreversible switch of perspective.
The Structure of Scientific Revolutions was originally published by the logical positivists of the Vienna Circle in the International Encyclopedia of Unified Science in 1962. Kuhn published a longer version of it that same year. Kuhn's purpose of this text is to argue the accumulation of new knowledge does not move in a linear fashion in the transformation of scientific fields. He states, if science is the constellation of facts, theories, and methods collected in current texts, then scientists are the men who, successfully or not, have striven to contribute one or another element to that particular constellation. Kuhn continues, scientific development becomes the piecemeal process by which these items have been added, singly and in combination, to the ever-growing stockpile that constitutes scientific technique and knowledge. Since Kuhn is approaching this topic as a historian, he claims that, as a historian, he has two tasks. The first task is to determine by what man and at what point in time each contemporary scientific fact, law, and theory was discovered. The other task is to describe and explain the congeries of error, myth, and superstition that have inhabited the more rapid accumulation of the constituents of the modern science text. Citing Alexandre Corre's work in the area of writing on the history and philosophy of science, which, according to Kuhn, indicates the possibility of a new image of science. Kuhn asserts that the goal of his text is to delineate that image by making explicit some of the new historiography's implication. Normal science, the activity in which most scientists inevitably spend almost all of their time, is predicated on the assumption that the scientific community knows what the world is like, he states. Kuhn further asserts, normal science, for example, often suppresses fundamental novelties because they are necessarily subversive of its basic commitments. Normal science, according to Kuhn, means research firmly based upon one or more past scientific achievements that some particular scientific community acknowledges for a time as supplying the foundation for its further practice. He uses the term paradigm, which is a particular set of concepts, theories, methods, and standards that practitioners use to validate contributions to a field, to describe the structure in which normal science thrives in solving puzzles. Prior to the existence of a paradigm, a pre-paradigm exists where individuals' activities and experiments are not guided by a well-defined paradigm. The pre-paradigm period, in particular, is regularly marked by frequent and deep debates over legitimate methods, problems, and standards of solution, though these serve rather to define schools than to produce agreement, he states. Kuhn says, when the individual scientist can take a paradigm for granted, he need no longer, in his major works, attempt to build his field anew, starting from the principles and justifying the use of each concept introduced. That can be left up to the writer of textbooks. Once a paradigm is established, scientists working in it follow rules, methods, and create models in which to learn from and apply in given situations. He says, normal science does not aim at novelties of fact or theory and, when successful, finds none. Kuhn continues, discovery commences with the awareness of anomaly, for example, with the recognition that nature has somehow violated the paradigm-induced expectations that govern normal science. When anomalies arise and persist, or are prolonged, within a normal scientific paradigm that scientists cannot solve, that can lead to a crisis in which change can occur. Both during pre-paradigm periods and during the crisis that lead to large-scale changes of paradigm, scientists usually develop many speculative and unarticulated theories that can themselves point the way to discovery, he claims. Kuhn says, anomaly appears only against the background provided by the paradigm. The more precise and far-reaching that paradigm is, the more sensitive an indicator it provides of anomaly and hints of an occasion or paradigm change. All crises begin with the blurring of a paradigm and the consequent loosening of the rules for normal research. In this respect, research during crisis very much resembles research during the pre-paradigm period, except that in the former, the locus of difference is both smaller and more clearly defined, he claims.